Okay, so I find that it is helpful to still draw a free body diagram to start the questions. So an object is swung in a vertical circle with a radius of 0.75 meters. What is the minimum speed needed? Okay, so minimum speed. That means we need to use it at the top, okay? So we say that our object is at the top because we're trying to find minimum speed. So I draw my center and go out. So going down, I have Ft because it's like it's being held right there, and I have Fg. So they're both going down toward the center of the circle. So I can say Fc is equal to Fg plus Ft. But then we just said to find minimum speed, at the top of the circle, we set Ft equal to 0. So we say this is 0. So Fc then is just equal to Fg. Now I know information about my radius is 0.75 meters. So, and I'm trying to find speed. So I look at my force is going to be m times AC is equal to m times g. Well, there's two options for AC. The one that looks like I need to use it is v squared over r. So I go m times v squared over r is equal to mg. You can cross off the m's because they're the same on both sides. And I'm solving for v. Right now v is divided by r, so I multiply by r, multiply by r. It is squared, so I square. So now I have v is equal to the square root of g times r. So one calculation. So if you do a little bit of work to figure out how all of the equations work together, then you only have to put one thing into your calculator, which is kind of nice. So then v is equal to the square root of 9.81 meters per second squared times by 0.75 meters. They're excited about learning. Okay, so v is equal to 2.7 meters per second. Make sure that you've squared it. If you just got an answer of like 7.35, you haven't squared it yet. Square rooted it. Thank you. Good? Okay, example 2. A string requires a force greater than 135 newtons in order to break it. A 2 kilogram mass is tied to the string and whirled in a vertical circle with a radius of 1.1 meters. What is the maximum speed that this mass can be whirled without breaking the string? Okay, so maximum speed now, I'm thinking about how much tension, because I'm looking, it says it has a maximum of 135 newtons. So it's like the amount of tension. Is the tension more or less at the top of my circle or the bottom when I'm holding it? At the bottom, yeah. Because at the top, there's a lot less tension. I don't have to hold it very tight. If you're holding something tight, the tension is strongest at the bottom. So we look, for these types of questions, we need to look at the object at the bottom. So we have our Fg going down and our Ft going towards the center of the circle. So it's important to just kind of conceptualize what's happening first, draw a diagram, and then you can set up your equation. Don't just run into the math. Make sure you set things up properly. So we have Fc is equal to Ft minus Fg. So I can set Fc equal to m times v squared over r. This is equal to Ft, that's what I'm trying to find out. And, or no, I'm trying to find out V, sorry. I know my Ft, and I can set Fg equal to m times g. Okay, now I'm going to solve for speed. So I want my v to be all by itself. Right now, v is divided by r, so I'm going to multiply everything by r. And then divide everything by m. And then square root it. So now I have v is equal to the square root of ft minus mg divided by m, all times by, oh, this is all times by r.
Do you multiply by r first?
Yeah, so it's like because here, so multiply your top fraction by r. So, let's put this in. So v is equal to square root of 135 newtons minus 2 kilograms times by 9.81 meters per second squared. All this times by 1.10 divided by 2.0 kilograms. So V is equal to 7.97